Did you know it takes over 22 hours for a signal from Earth to reach Voyager 1? Since their launch in 1977, the two Voyager spacecraft have traveled billions of kilometers from the Sun, journeying farther than any human-made object in history and have even ventured into interstellar space. These aging explorers continue to send back astonishing and one-of-a-kind insights into the vast and mysterious universe. Some time ago, Voyager 1 transmitted remarkable data that immediately drew attention from scientists. One thing was clear: something powerful had occurred somewhere in the cosmos. But as researchers soon realized, this event also unveiled a puzzle of cosmic proportions. Keep reading to discover what Voyager 1 encountered deep in space and what kind of astronomical mystery it unveiled. The scale of the universe is truly immense. The average distance from the Earth to the Sun is about 150 million kilometers, a figure that already defies comprehension. But compared to Voyager 1's staggering 25 billion kilometers from Earth, even that distance seems modest. Only one other human-made object has traveled nearly as far: Voyager 2, which is currently about 20 billion kilometers away from the Sun. What makes the Voyager mission even more remarkable is that neither probe was originally intended to go this far. Their initial mission was to study the then largely unexplored outer planets. Designed to last just 10 years, they have far exceeded expectations, demonstrating that technology from the 1970s was capable of exploring regions of space once thought unreachable. Of course, by today's standards, the technology on board is severely outdated. For example, a smartphone has millions of times more storage capacity than the Voyager probes. Their mission data is still stored on magnetic tape with just 536 megabits of capacity, and their transmission speed is nearly 40,000 times slower than modern mobile networks. Despite this, Voyager 1 and to have done something no smartphone or spacecraft ever has. They have entered interstellar space. Launched on August 20th and September 5th, 1977, with Voyager 2 launching before Voyager 1, both probes began by studying the outer planets. After capturing the first and, in some cases, still the only images of Jupiter, Saturn, Uranus, and Neptune, along with vast amounts of scientific data, their mission was extended beyond the solar system. What Voyager probes discovered in interstellar space. On August 25, 2012, Voyager 1 became the first spacecraft to reach the outer boundary of the solar system. Scientists were particularly interested in how the Sun interacts with particles and magnetic fields beyond the heliosphere, the vast bubble dominated by the Sun's magnetic field and solar wind. This region acts like a shield, protecting the solar system from much of the radiation in interstellar space. Voyager 1's crossing into this boundary gave researchers their first direct insight into this interaction. Its twin, Voyager 2, reached the same region on November 5, 2018, allowing a valuable comparison between the two datasets. The results revealed something unexpected. Instead of the heliosphere being an irregular, stretched-out shape as once thought, it appeared to be much more spherical and symmetrical. More surprises followed. Before reaching the heliopause, the outermost boundary of the heliosphere, Voyager 1 detected a sudden drop in plasma flow and intense turbulence in the surrounding interstellar medium. Researchers assumed this meant the boundary region was thick and unstable, but Voyager 2 found something entirely different: a boundary that was thin and surprisingly stable. What could explain this contrast? Scientists believe solar activity may be the key. When Voyager 1 crossed the boundary, the Sun was in a quiet phase, allowing more interstellar radiation to penetrate deeper into the heliosphere. But when Voyager 2 arrived, the Sun was highly active, and the increased solar wind may have stabilized the boundary. Voyager 2 also found evidence of a large magnetic structure just beyond the heliopause, which offers additional shielding from cosmic radiation. This magnetic field is stronger than any inside the heliosphere and appears to be created by magnetic currents that flow outward and weaken as they reach the boundary. With each new solar cycle, the Sun's magnetic field flips, restarting this process in reverse polarity. Moreover, The probes revealed that the interstellar magnetic field is 2 to 3 times stronger than previously believed. This means interstellar particles exert up to 10 times more pressure on the heliopause than scientists once thought. Despite these discoveries, we are still far from understanding the full nature of the boundary between our solar system and interstellar space. The region remains largely unexplored. Only these two probes have crossed it. For a more complete picture, future missions will be necessary. But time is running out. The end of the Voyager era? The Voyager probes are approaching the end of their operational lives. Technical issues and communication losses are becoming increasingly common. Not long ago, engineers had to reactivate a set of long-dormant thrusters on Voyager 1 just to keep the mission going. To conserve power, NASA has also shut down most of the onboard instruments, so only 3 of the original 10 are still functioning. Luckily, one of those remaining instruments is Voyager 1's plasma sensor. In late 2022, it was still active, and what it recorded stunned even seasoned scientists. The most powerful gamma-ray burst ever recorded on October 9, 2022. Voyager 1 was traveling through deep space at around 61,000 kilometers per hour when it detected a massive spike in high-energy radiation. 19 hours later, that same burst struck Earth. It was a gamma-ray burst, already among the most energetic events in the universe, but this one was different. It was 70 times stronger than anything ever recorded. Known as GRB2-1009A. The explosion was so intense that it temporarily blinded gamma-ray detectors on Earth and even altered the planet's ionosphere. And yet, it occurred to billion light-years away. Due to its extraordinary brightness, the event earned the nickname BOAT, an acronym for brightest of all time. Scientists estimate that an event of this scale happens only once every 10,000 years. But what caused it? That question puzzled experts for months. It was assumed to be a long gamma-ray burst, typically caused by the collapse of a massive star in a supernova. However, some key supernova features were strangely absent, both during the burst and in its aftermath. One major complication was the intensity of the burst itself. It was so bright that it masked any evidence of a supernova for months. It was like trying to spot a car in front of you with its high beams on. You can't see the car until the lights fade. Finally, after more than 6 months, astronomers used the James Webb Space Telescope to examine the fading afterglow. Its near-infrared spectrometer NIRSPEC revealed telltale signs of elements typically produced in a supernova. But that made the findings even more surprising. The explosion wasn't unusual in terms of the supernova itself. So how did a relatively standard stellar collapse produce such an intense gamma-ray burst? Researchers suspect it had to do with the shape and speed of the explosion. When rapidly spinning massive stars collapse, they can form highly focused jets of energy moving at nearly the speed of light. In this case, the jet was among the narrowest ever seen, concentrating energy into an extremely bright beam. Still, the mystery isn't fully solved. Astronomers believe other unknown factors might be involved. It could take years to fully understand how a seemingly ordinary supernova unleashed such powerful radiation. One thing is certain: as long as Voyager 1 keeps flying, it may still surprise us again, delivering clues from the edge of our solar system and beyond, one signal at a time.